Writing equations of lines. There are different forms of equations. There's standard form, slope-intercept form, point-slope form, horizontal line, and vertical lines. We're going to talk about all of these different forms of equations. The first one, standard form, is ax plus by equals c. Standard form is not a form that we can plug things directly into or get things directly out of, but you may be asked to write an equation in standard form, or you may be given an equation in standard form. You also need to note that standard form cannot contain fractions. So if you're asked to put an equation in standard form and you have fractions, then you'll need to multiply everything in the equation by the least common denominator to get rid of the fractions. The next form of an equation is slope-intercept form, which is y equals mx plus b. In slope-intercept form, m stands for the slope of the line, that's the coefficient of x, and b is the y-intercept. The next form of an equation is point-slope form. Point-slope form is y minus y sub 1 equals m times x minus x sub 1. In this form of the equation of a line, the y and the x that don't have the sub 1's beside them, those stay a y and an x. But the m, just like in slope-intercept form, represents slope, and the y sub 1 and the x sub 1 are the coordinates of our point. The last two forms of equations are horizontal line and vertical line. These are y equals some number and x equals some number. And the way that we can remember these are by using the acronyms HOI, VUX, which remind us that all horizontal lines have a slope of 0 and look like y equals some number, and all vertical lines have a slope that's undefined and look like x equals some number. So these are the different forms of equations that we'll be dealing with. Write an equation of a line with the given information. Well, they've given us the information in A that m is negative 4 over 9 and b is 6. So remember, m stands for slope, b stands for y-intercept. So since they've given us the slope and the intercept, we're going to use slope-intercept form of a line. And remember, slope-intercept form is y equals mx plus b. So all we're going to do is take the information that they've given us and put it into that equation of the line. Okay, so y is going to stay y. We're replacing m with what they told us that m is. M is negative 4 over 9. X plus b, which is 6. So now we've written the equation of a line in slope-intercept form. B is also giving us the slope and the y-intercept. So again, we're just going to plug that information into slope-intercept form. So we would have y equals, my m is 7, x plus b, so that's plus a negative 1. Well, let's clean that up a little bit because we don't want two signs touching each other. So I have y is equal to negative 7x minus 1. And that's our equation in slope-intercept form. For C, we have a slope of 0 and a y-intercept of 9. Okay, so if we were to plug this into slope-intercept form, that would give us y equals 0x minus 9. But 0 times anything is 0, so that just turns to 0, so y equals negative 9. Well, we know that anytime, because of Hooy-Vux, we know that if we have a slope that's 0, then our equation is going to be y equals some number. It's y equals whatever the y-intercept is. So that's what our line is. So we didn't have to plug it into slope-intercept form. Once we found out that the slope was 0, we knew it was just going to be y equals some number. So it's y equals -9. But it's okay if you plug it into slope-intercept form too. We'll get the same answer. D is written a little differently. It's given us a point, 0, 2, and it says that the slope is 1/2. Well, we know that our y-intercept is where it crosses the y-axis, and anytime we're finding intercepts of lines, remember we always plug in 0 for the opposite letter. So, since in this point my x is 0, then we know that this is the y-intercept. Alright, so this point right here is my y-intercept. They've just written it a little differently. So, now that we know that that's the y-intercept, we can use slope-intercept form. Y equals m, which is 1/2, x plus my y-intercept, which is 2. And that's it. Okay, here are a couple more. E says that m is, or my slope is 3/8, and my y-intercept is 0, -2. So they specifically told me that this was my y-intercept. But again, I knew that since my x was 0, if my x is 0 and I have a number for y, that's my y-intercept. If I had something like this, if my y was 0 and I had a number for x, I would know that that's my x-intercept. Okay, so I have a slope and my y-intercept. I'm going to plug it into slope-intercept form. Y equals m, which is 3/8, x plus a -2. Well, plus a -2 would just be -2, so let me just write it like that, -2. Okay, so we had an equation where the slope was 0, and whenever the slope is 0, Hooy, we know it's y equals some number. Here it says the slope is undefined. Well, because of Vux, we know that all vertical lines have an undefined slope, and their equation is x equals some number. So since my slope is undefined, I know that it's going to be x equals some number. Well, they've given me a point, so my number is going to be whatever my x is. So it's going to be x equals 4. Just to expand on this a little, if they had instead said that I had a slope of 0, passing through this point, then my equation would be y equals what the y is. Y equals -1. Let's try just a couple more of those. Alright, so we're using Hooy-Vux. Okay, so if they said that I had an undefined slope passing through the point 3, 7. Okay, so undefined means that it's going to be x equals some number. So for this, it would be x equals whatever the x is, and my x is 3, so x equals 3. If it said that I had a slope of 0, and it's passing through the same point, 3, 7, well, because of Hooy, if my slope is 0, it's going to be y equals some number. So it would be y equals whatever the y is, and the y is 7. Write an equation in point-slope form, then rewrite in slope-intercept form and standard form. Okay, so let's recall, we know that point-slope form is y minus y sub 1 equals m times x minus x sub 1. Okay, so they have given us the slope and a point. Of course, my slope is m, and then my point is going to be my x sub 1 and my y sub 1. So all I have to do to get it in point slope form is to take the information that they've given me and plug it into that equation of the line. Okay, so the y and the x that don't have the little ones beside them stay a y and an x. Okay, so I have y minus my y sub 1, which is negative 3, equals m, and my m is negative 5, times x, which is just stays in x, minus x sub 1, which is 8. Okay, always clean it up, and you don't want two signs touching. So that y minus a negative 3, that's just y plus 3, equals negative 5 times x minus 8. And that is my equation in point slope form. Okay, so now I want to take that and write it in slope-intercept form. Well, remember, slope-intercept form is y equals mx plus b. So in slope-intercept form, I need to get the y by itself. And remember, anytime we're dealing with equations, if we have parentheses, we need to get rid of the parentheses first. So the first thing I'm going to do is distribute my 5, or my negative 5, and that gives me y plus 3 equals negative 5x, and a negative 5 times negative 8, that would be a positive 40. Then to get y by itself, I'm going to subtract 3. And that gives me y equals negative 5x plus 37. Okay, so now that's my equation in slope-intercept form. Okay, so then to get it in standard form is ax plus by equals c. So the x and the y need to be on the same side of the equation. So I'm going to add 5x to both sides of the equation. And that gives me 5x plus y equals 37. And that's my equation in standard form. All right, let's do another one. My slope here is 2/3 and my y-intercept is 3. Sorry, not my y-intercept, my x-intercept. So I have the point 3, 0 in my line. So I'm going to use point slope form. So for point slope form, y minus y sub 1. So my y sub 1 is 0. Equals m, so that's 2/3, times x minus x sub 1, which is 3. Okay, so that is point slope form. To get it in slope-intercept form, I need to get the y by itself. Well, y minus 0 is just y. So I just have y equals, I'm going to distribute the 2/3. So I have 2/3 x. And then when I multiply 2/3 times negative 3, let's go over here and see what happens. 2/3 times negative 3. Well, that's the same as negative 3 over 1. Well, the 3 on the bottom and the 3 on the top would cancel, and that would just give me a negative 2. Or if that confuses you, if you don't want to cancel, you can just multiply those together, and you say negative 6 over 3, and when I divide that, I still get negative 2. So when I multiply 2/3 times negative 3, I get negative 2, and that's my equation in slope-intercept form. Alright, so then to get it in standard form, I I need to get my x and my y on the same side of the equation. So I'm going to subtract 2/3 from both sides, 2/3 x. So that gives me 2/3 x plus y equals -2. Okay, so that's my ax plus by equals c, but remember I said at the very beginning, standard form cannot contain fractions, and we have a fraction here. So we need to get rid of the fractions, and the way that we get rid of fractions in an equation is multiply every term times the least common denominator. So I'm going to multiply every term times 3. So in the fraction, the 3's are going to cancel, and I'm left with 2x plus 3 times y is 3y equals -2 times 3, which is -6, and that is standard form. All right, here we're given 2 points. Well, I have point-slope form, slope-intercept form, and standard form. I don't have point-point form. So what we're going to have to do, since the two types of equations that we can plug things into, point-slope or slope-intercept, they both require a slope. Well, if you'll remember, we learned how to find the slope in the previous lesson by using this formula. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's what we're going to have to do first, is we're going to have to use those 2 points and find the slope, and then use that to write the equation of the line. Okay, so if I want to find the slope using the line that contains these 2 points, I'm going to plug it into the slope formula. So remember, each point is an x and a y. Y sub 2, this is my y sub 2, minus y sub 1, that would be 2 minus 4, over x sub 2 minus x sub 1. So that would be 6 minus 3. All right, so that would give me a -2 over 3. So my slope is -2/3. Now, to put the equation in point-slope form, we only need one of the points, and it does not matter which of the 2 points you choose to use. It's going to look different when it's in point-slope form, but once you simplify it and get it in slope-intercept form or standard form, it's going to be the same no matter which point you choose to use. I am going to use the first point. It doesn't matter, but that's what I'm going to use. Okay, so I'm going to use this point. So that means we don't need that second point anymore. All right, so I'm using the point 3, 4 and the slope -2/3 to put it in point-slope form. Okay, so point-slope form is y minus y sub 1, so that would be 4, equals m, which is my -2/3, times x minus x sub 1, which is 3. Okay, so that is my equation in point-slope form. To get it into slope-intercept form, I need to get y by itself. But first, I need to get rid of the parentheses. So I'm going to distribute the -2/3. Okay, so I have y minus 4 equals -2/3 x. Then a negative times a negative, that would be a positive. And remember, if I multiply -2/3 times -3, the 3's are going to cancel, and that becomes a positive 2 over 1, which is just 2. So plus 2. And then one more step to get it in slope-intercept form. I need to get the y by itself, so I'm going to add 4 to both sides. Okay, so I get y equals -2/3 x plus 6. So that is slope-intercept form, and then the last thing I need to do is get it in standard form. Okay, so x and y need to be on the same side, so I'm going to add 2/3 x to both sides. So I have 2/3 x plus y equals 6. Okay, what's wrong with this? It has a fraction. So I need to multiply everything by the least common denominator to get rid of the fractions, or the fraction. And the least common denominator, or the only denominator, is 3. So I'm going to multiply everything times 3. And that gives me, the 3's cancel, so I have 2x plus 3y equals 18. And that's my equation in standard form. Okay, last one. Again, they've given us 2 points. So the first thing we have to do is find the slope of the line. Okay, so for the slope, it's y2 minus y1 over x2 minus x1. Okay, so my y's are both 2. So it would be 2 minus 2 over my x's, which would be -1 minus 8. Well, 2 minus 2 is 0, and that would be over -9, but 0 over anything is 0. Alright, so if I'm going to plug this into point-slope form, like I said, it doesn't matter which point you use when you're plugging it into point-slope form. I'm going to use the second point this time. Okay, so if I use that, I don't need the first point anymore, and point-slope form is y minus my y sub 1, which is 2, equals m, which is 0, times x minus x sub 1, which is -1. Okay, so if I simplify this, I get y minus 2 equals, well, 0 times all of this, 0 times anything would just be 0. So I have y minus 2 equals 0, and that's, if I like I said, if I simplify that, that's what I get. So that would be my point-slope form. Slope-intercept form, if I move the 2 over to the other side of the equation, I get y equals 2. And standard form, there's no x to move over to the other side of the equation, so that would be standard form also. So my equation is just y equals 2. And we know that that is, because of Hoy-Vux, we know that that is a horizontal line.